Mr. Ahmed here again. Today we're working with similar polygons, which we will call 8.3. This corresponds with 8.1 in your Big Ideas textbook. Similar polygons, what are they? And how do we use them to find missing sides is our essential question. Similar polygons are exactly the same shape, but they're not necessarily the same size. This little squiggly mark indicates that they are similar. Okay, there's no equal sign underneath it. So this marking is what we'll see for similar figures. The corresponding angles are congruent. That's what makes them similar. One could be smaller, the other bigger. The scale factor. That's an important piece for us. The scale factor is the ratio of the lengths of the corresponding sides. Okay, the ratio of the lengths of the corresponding sides. So I'm going to call that the side length ratio. All right. As we work through this, we'll see that since the two polygons are similar, their sides are proportional in length. So we'll set up numerous proportions to find the missing sides using our scale factor. So first example says we are going to look at two quadrilaterals, so they have four sides. Notice the way they're named, A, B, C, D, E, F, G, H. That means angle A corresponds with E, D with H, just like we've done in the past. So those are the angles that are congruent. So A and E come first. So angle A is congruent to angle E. Angle B would be congruent to our second one, F. Angle C is congruent to angle G. And angle D is congruent to angle H. Now I'm going to mark those as well with some tick marks. A, E, F, B I'm putting 2. C I'm going to actually use a different type of marking with some dashes. And D, 1, 2, 3. D, 1, 2, 3 for H. Those angles are congruent. Now the proportional sides. The sides that correspond are proportional. So when I set up the ratio of one of the sides, it doesn't really matter what, AB corresponds with EF. So AB over EF. That would be how I'd find the scale factor. And that would be equal to another pair of corresponding sides. Now in this case, I did big over small. You could have also done it small over big. That is not imperative. The choice is yours. So AB, EF would have to equal BC, another pair of corresponding sides, over small FG. And that would equal DC over HG, as those pair correspond, and AD over EH. So that would be the proportion of the sides. Now typically we aren't going to put all four together. We just use 2 and then cross multiply to solve. So next example will involve us setting up the scale factor and finding a missing side. So this problem has two pentagons, A, B, C, D, E, and J, K, L, M, N. Now it's a little bit tough for me to tell which sides correspond in this one. I'm going to go with 6 being J, K. So JK corresponds with AB. JK, AB, the first two letters. So we will go with big over small. So the scale factor is 6 over 5. We found it. Now, in order to find the proportion for the missing sides, we're going to use that same scale factor, 6 over 5, has to equal, well, let's see here. X corresponds LK, CB. So 6, X, and 4. Then we can cross multiply to solve. 6 times 4 is 24, equals 5X. And X is equal to 4.5. We found the missing side. So that's going to be our main goal, setting up a proportion to find missing sides. Now, if you did small over big, that's fine. Choice is yours. Just make sure you keep it the same way throughout the whole problem. I can't do big over small and then small over big. Okay? So problem number 3 tells us that we are going to work with some triangles that are similar. And it asks us to find the scale factor of the smaller triangle to the larger. So make sure you read the instructions. This one says to do small to large. So here is our small. This is the large. So we would say small over large is equal to 30 over 40, which reduces to 3 over 4. Using the reduced fraction will make solving the problem a little bit easier, smaller numbers. It now says to find the value of x. So in this case, we did small over big. So 3 over 4 is equal to, finishing up the other side, 3 over 4, 18 corresponds with our x plus 15. So when we set this up, 18 on the top, x plus 15 on the bottom. And cross multiply to solve. Make sure we distribute. 3 times x plus 15 equals 4 times 18, which is 72. Distribute. 3x plus 45 equals 72. And when we finish solving, x is equal to 9. So the next one involves the perimeter. The ratio of the perimeter is going to be equal to the ratio of the sides in a similar figure. So you could approach this a couple ways. You could find the 2 missing sides by setting up 2 proportions, or we can use the perimeter to set up the proportion. So when I set up my scale factor here, 5 corresponds with 3, so the scale factor is equal to 5 over 3, corresponding sides. Now when I do the perimeter, I can put the big one on top, small one on the bottom to solve for the perimeter. So when I set up my proportion, we're doing big over small. Perimeter, PER, of the big over the perimeter of the small is equal to the scale factor 5 over 3. Okay? Now when we find the perimeter of the big one, we have to add up the sides. 5 plus 7 plus 6, that's 18. So we'd have 18 over our unknown x is equal to 5 over 3. And then we will cross multiply to solve. 54 equals 5x. And x is equal to 10.8. So x stands for the perimeter of the small figure. So the perimeter of the small one is equal to 10.8 units. We have found the perimeter. Okay, our next example involves us finding some missing angles. So keep in mind that if the figures are similar, the angles are congruent, that correspond. So when I look at the x, angle D, D is last, P is last. So D is equal to P. X plus 34 is equal to 97. And we can solve that one by subtracting. X is equal to 63. We found x. Now our y, angle R corresponds with C. So R is equal to C. I'm going to put a box around those because those are corresponding. Now I wouldn't have been able to know that without using the statement. It wasn't extremely obvious to me which ones were congruent. I had to read it using the statement to see which ones are equal. So 3y minus 13 is equal to 83. When we solve, 3y equals 96, and y is equal to 32. And we are going to skip number 6 because we did not go over similar triangles, so that problem will not be necessary for us today. Have a good rest of the day.